Right now, let's look on how to find the distance between two functions. The distance between two functions. For now, we are going to look on a straight line and a quadratic. Straight line and a quadratic. F at x is equal to ax squared plus bx plus c. And then let's say we've got another function, g at x is equal to, let's use mx for the gradient, is equal to mx plus c. Right. Let's say you are to find the distance between the two functions, the distance between the two functions. In order to find the distance here, remember that the distance is a difference between 2 points. We've got point F and point G. We are to find the distance between point F and point G. In other words, we are going to say F minus G. Let's try to indicate this as a function. Right, let's say this is the function of f. That's the function of f. And let's indicate a straight line there. Let's say we've got g here. And then now we are to find the length of EF, the length of EF. This is the distance between two functions. It's function of f, function of g. If you are to find the length there, it's where you are going to say EF, the above one minus the below one there. It's EF equals f at x minus g at x. F minus g, the distance between 2 points. You just find the difference. This means that we are going to have a x squared, which is our f, plus bx plus c, minus g at x, which is mx plus c. And then let's solve the brackets there. We are going to have ax squared plus bx plus c minus mx minus c. Okay, c minus c. We are now having ax squared plus bx, this will subtract that, minus mx. This is the distance of EF. This is the length of EF. The length of EF will be given by ax squared plus bx minus mx. Right, let's say now we are being asked to find the maximum distance. This is the distance. And then let's say you're being asked to find the maximum distance. Let's say our function of f is given by the equation minus x squared plus 4x plus like that. Let's say the function of g is given by x plus 2. X plus 2. We've got the two functions. They represent this. Right. We are to find the length EF. EF. Remember that we are now have to find the maximum length. This is the length of EF. Now we are to find the maximum. Right. The length of EF is given by f at x minus g at x. We are using now these equations. It's minus x squared plus 4x plus 12 minus this, which is x plus 2. We solve the brackets. It's minus x squared plus 4x plus 12, this and that, it's minus x, this and that, it's minus 2. Like terms, it's x squared, 4x minus x, that will be 3x. 12 minus 2, that is 10. This is the length of EF. It's the length of EF. But then we are to find the maximum length of EF. This is the length of EF. The length of EF. That's the length of EF. Now we are to find the maximum length. For maximum or minimum, you always derive. For maximum or minimum, we derive. EF, we find the derivative of this equation, which is the length of EF, because we are to find the maximum length. Let's firstly write this equation as it is. Minus x squared plus 3x plus 10. For maximum, we derive. 2 times negative 1 is negative 2. And then we subtract 1, it will be negative 2x. 1 times 3 is plus 3. Like that. That is a derivative. We are to find the maximum length. The maximum length. So, for maximum we derive. After deriving, we let the derivative to be 0, because this is a gradient now. So the gradient at maximum or minimum, it is equal to 0. Therefore we derive and let the derivative to be 0. We let EF to be equal to 0. Therefore, minus 2x plus 3 will be equal to 0. And then we solve for x. Minus 2x will be equal to negative 3. We divide by negative 2 on both sides. Therefore, our x will be equal to positive 3 over 2. Remember, we are looking for the maximum length of EF. Maximum length of EF. After finding this value, you take that value into the original to find the maximum length. Therefore, the maximum length, this is the length of EF, and then for maximum length, we have derived as that, and then now let's find the maximum length. EF will be equal to, we are using this value at maximum, this value of x at maximum, substitute it into EF. It's minus 3 over 2. This is what we have to calculate. Plus 3 into 3 over 2. Plus 10. It will be like that, and then the answer here. The answer will be 49 over 4. Units, because we are talking about the length. It's 49/4 units. This is the length of, it's the maximum length of EF. This is the maximum length. This is the maximum length. Remember that to find that length, that maximum length, we firstly subtract the two functions, the function of f and the function of g. Thereafter, we found that the length of EF is given by that. But for maximum, we let the derivative to be 0 at maximum, so that we are going to solve for x, and then after, we substitute the x value into the length of EF to find the maximum length. That's how to find the maximum length. It's either maximum or minimum we derive. So let's say you were not to derive. Let's see what will happen. The length of EF is given by, negative x squared plus 3x plus 10. That's the length of EF. We are to find the maximum length. Remember that we need to firstly find the x value, so that we'll use that x value to find the maximum length, which is the value of y. The maximum or minimum value, it's a y value at the maximum point or at the minimum point. It's a y value. It's a y value at this point. This is the maximum point. So when you talk of a maximum value there, we are talking about the value of y. The minimum value, again, is the value of y. So it's either you go like that up to, this is vertical. This is a vertical line. That's why we are saying the maximum value represents the value of y at the turning point, because it is just vertical. Right, here we are to find the maximum length of EF without deriving. Remember that this is maximum point of a quadratic function, minimum point of a quadratic function. The x value at maximum is given by minus b over 2a. It's minus b over 2a. So let's use this. It's minus into, our b is 3, divided by 2. Our a is negative 1. Right. It's negative 3 over negative 2. 2 times negative 1 is negative 2. Therefore, x is 3 over 2. It's positive 3 over 2. The same as this value of x. The same as that value of x. And then we take this value into the original, into the length of EF, to find the maximum length of EF. It can be anywhere. Let's say, let us erase this. Even if your function is facing downward like that, and you have this, let's say this is the function of g, the function of h, Right. Let's say you've got this. Now let's put another point here to be our E. Right. This is what we have there. If we may to write the equation. This, let's say g at x is given by this equation. Let's say g at x is given by that equation. Right. Let's say we have the two equations. And we are to find the length of ED or DE. We are to find the length of ED or DE. We do the same. The above function minus the below one. It's g at x minus h at x. The above one minus the one that is below. Let's check. The length of DE will be equal to g at x minus h at x. And then substitute. It's minus x squared plus 2x plus 3. And then we subtract h at x. It's minus 2x plus 3. Let's solve the brackets. It's minus x squared plus 2x plus 3. Negative by negative, it's plus 2x. Negative times that, it's minus 3. And then let's add the like terms. The length of DE will be given by minus x squared. 2x plus 2x will give us 4x. 3 minus 3, 0. This is the length of DE. The length of DE. That's the length of DE. Right, let's now find the minimum length. The minimum length of DE. The minimum length of DE. For maximum or minimum, we derive. DE is given by that. So since we are looking for the minimum distance or minimum length of DE, we will have to derive this equation. DE is given by minus x squared plus 4x, and then now for maximum we derive. For maximum we derive. So it's 2 times that, it's negative 2x, 1 times 4, it's plus 4. And then remember, we are at maximum here. This is the gradient at maximum. Therefore, or at minimum, since we are finding the minimum distance. For minimum, we derive. At minimum, the gradient is equal to is equal to 0. Therefore, minus 2x plus 4 is equal to 0 at minimum. We let the derivative to be 0. Minus 2x will be equal to minus 4. We divide by negative 2. That means our x will be equal to positive 2. This is the x value at minimum. The x value at minimum. And then we are to take this value, substitute it into the original equation. That means our dE will be equal to minus into, we substitute by 2 in the place of x, all squared plus 4 times, we put 2 in the place of x. Remember, we are substituting into the original, not into the gradient. It's minus 4 plus 8. 8 minus 4, that will be 4 units. It's 4 units. Which means the minimum length of dE is 4 units. This is the minimum length. The minimum length. So always for maximum or minimum length or minimum distance, we derive. For maximum or minimum length, we derive. So let's stop here with finding the distance between two functions.